Hey everybody, and welcome. It is December 9th, 2023, and I am the Shy Hat, and we're here to complete our daily challenge from TryHackMe with the Advent of Cyber 2023 event. Let me turn on my mouse highlight. Okay. All right, so we're doing Advent of Cyber 2023. This is a series of challenges, beginner cybersecurity challenges. I'll drop the link in the chat for anybody who wants to participate. And so this is an event that's going from December 1st until December 24th. And the goal is to solve a different beginner-friendly cybersecurity challenge each day. So we are on day 9. So today we're going to be doing some malware analysis. Specifically, we're going to be taking a look at some C# code. Let's begin by clicking on the green Start Machine button over here. Let's make the text a little bigger so that we're better able to see what's on the screen and we can all follow along together. All right, so we're going to click on the green Start Machine button over here. So it's going to create a split screen, this is the virtual machine of the day for today's challenge being spun up. So we just need to wait here a little bit, but while we're waiting for this machine over here to initialize, we can take a look at what's going on today. So today's learning objectives are: in this task, we will focus on following vital learnings to assist Forensic Blue in analyzing the retrieved malware sample. We're going to learn the foundations of analyzing malware samples safely. We're going to learn the fundamentals of .NET binaries. We're going to use the DNSpy tool for decompiling malware samples written in .NET. And we're going to be building an essential methodology for analyzing malware source code. Alright, so malware handling 101. So warning, handling a malware sample is dangerous. Always take precautions during your analysis. As mentioned, handling malware is dangerous because it is software explicitly designed to cause harm, steal information, or compromise the security and functionality of computer systems. Given this, we will again introduce the concept of malware sandboxing. A sandbox is like a pretend computer setup that acts like a real one. It's a safe place for experts to test malware and see how it behaves without any danger. Having a sandbox environment is essential when conducting malware analysis because it stops experts from running malware on their actual work computers, which could be risky and harmful. A typical environment setup of malware sandbox contains the following: network controls. Sandboxes often have network controls to limit and monitor the network traffic the malware generates. This also prevents the propagation of malware in any other assets. Virtualization. Many sandboxes use technologies like VMware, VirtualBox, or Hyper-V to run the malware in a controlled, isolated environment. This allows for easy snapshots, resets, and disposal after the analysis. And monitor and logging. Sandboxes record detailed logs of the malware's activities, including system interactions, network traffic, and file modification. These logs are invaluable for analyzing and understanding the malware's behavior. All right, so we see that our virtual machine has finished initializing over here. So what we can do is we can take the virtual machine and we can bring it, we can put it in its own web browser tab by going down to this button down at the bottom over here in the middle of the screen, and clicking on this button, which is View in Full Screen. So we're going to click on that, and that's going to put the virtual machine in its own full screen browser tab right there. And we're going to go back to this tab here, the other web browser tab, and then we're going to close out this split view. And we do that by clicking on this button right here, which looks like a minus sign. Click on that one. and then we can see everything in full screen, which is a lot better for following along. So before moving forward, we're going to review the questions and the connection card seen below. So do we need to start the attack box today? No. Do we need to start a VM today? Yes. Is there split screen available? Yes. Is there a direct link available? No. Am I given credentials to connect directly to the VM via RDP, VNC, or SSH? Yes. All right, so we can skip this other section over here and go straight to the introduction of .NET compiled binaries over here. .NET binaries are compiled files containing code written in languages compatible with the .NET framework, such as C#, VB.NET, F#, or managed C++. These binaries are executable files with the .exe extension or dynamic link libraries, DLLs with the DLL extension, .dll extension. They can also be assemblies that contain multiple types and resources. Compared to other programming languages like C or C++, the languages that use .NET, such as C#, don't directly translate the code into machine code after compilation. Instead, they use an intermediate language, IL, like a pseudocode, and translate it into native machine code during runtime via a common language runtime environment. This may be a bit overwhelming, but in simple terms, it's only possible to analyze a C or C++ compiled binary by reading its assembly instructions, which are low level. Meanwhile, a C# binary can be decompiled and its source code retrieved, since the intermediate language contains metadata that can be reconverted to its source code form. So let's talk about basic C# programming. So based on the ELV's initial checks, it's been discovered that the retrieved malware is written in C#. So let's quickly discuss C#'s code syntax to analyze the sample effectively. Okay, so I'm assuming that the people watching are not necessarily very familiar with C# programming, so let's take a look at these code snippets. So first of all, we're going to talk about namespaces, classes, functions, and variables. So for this section, let's use the following code snippet over here. All right, so we have an internal class. We have a static void function, a static void main function with strings and arguments. Okay, and we have a public static void, another static public void function. All right, so what are these things? Okay, so we're talking first about a namespace. A namespace is a container that organizes related code elements such as classes into a logical grouping. It helps prevent naming conflicts and provide structure to the code. In this example, the names demo only is the namespace that contains the basic programming class. So what are classes? They define the structure and behavior of the objects it contains. In the example, basic programming is a class that includes the main function and the show output function. Moreover, the main function is the program's entry point where the program starts its execution. Function. Functions are a reusable block of code that performs a specific task or function. In this case, the show output function takes a string through the text argument as the input and uses it on the control.writeLine to print as its output. Note that the show output function only receives one argument based on how it's written. And variables. Variables are a name storage location that can hold data such as numbers, text, or objects. In this example, toPrint is a variable that handles the text "Hello World." Okay, so the next concept we're going to talk about is for loops. A loop is a control structure used to repeatedly execute a block of code a specified number of times. It typically consists of three main components: initialization, condition, and iteration. Let's use the example below. Okay, so for int I equals 1, int greater than or equal to, less than or equal to 5, I plus plus, which is add 1. Okay, and the loop executes the function control.writeLine I love Skitty. Okay, so in this example, the loop is initialized with 1 and stored in the variable I initialization. Checks if variable I is less than or equal to 5, the condition, and increments 1 to itself, adds 1 to itself every loop, also known as iteration. So in simple terms, the code snippet means that it will call the console.writeLine function 5 times, since the loop will count from 1 to 5. Loops can be immediately terminated using the code break. So the next thing we're going to take a look at are conditional statements. Conditional statements like if and else are control flow statements used for conditional code execution. They allow you to control which code block should be executed based on a specific condition. So if number greater than 5, console.writeLine, the number is greater than 5. Or else, console.writeLine, the number is less than or equal to 5. So based on the example above, if the if statement checks whether the number variable contains a number greater than 5 and prints to the string, the number is greater than 5. If that condition is not satisfied, it will go to the else statement, which prints the number is less than or equal to 5. Essentially, it will go to the code block of the if statement. If the if statement, code block of the if statement, if the number variable is 7, and it will go to the else code block if the number variable is set to 4. So 7 is kind of an arbitrary number that is greater than 5, and 4 is an arbitrary number that is less than 6. Okay, so importing modules. C# uses the using directive to include namespaces and access classes and functions from external libraries. So this is how we import modules. So using system. So that is how the system module is imported. So the code snippet above loads an external namespace called system. This means that this code can now use everything inside of the system namespace. So don't worry if you find the code snippets a little overwhelming. Once we start analyzing malware, the following sections will be much easier to understand. So let's learn a little bit about C2s. So C2 is command and control. So according to Forensic Blue, the retrieved malware sample is presumed to be related to the organization's remote mind control over C2 incident. So to build the right mindset in solving this case, let's look at a run-through below about malware with C2 capabilities. C2, or command and control, refers to a centralized system or infrastructure that malicious actors use to remotely manage and control compromised devices or systems. It serves as a channel through which attackers issue commands to compromised entities, enabling them to carry out various activities such as data theft, surveillance, or further malware propagation. So if we see here at this diagram, so the user executes the malware, and then the malware connects to the C2 server and asks for instructions. So here's the user and the C2 server. Okay, so the malware connects to the C2 server and asks for instructions. Then the C2 server responds with a set of instructions. And then on the victim side, the malware executes the instructions retrieved from the C2 server. And then the malware reports back the output to the C2 server. And then the cycle will loop over and over again. So seeing C2 traffic means that the malware is already being executed inside the victim machine, as detailed in the diagram above. In terms of the cyber kill chain stages, the attacker has successfully crafted and delivered the malware to its target, and potentially moves laterally inside the network to achieve its objectives. To expound further, malware with C2 capabilities typically exhibit the following behaviors. So it uses 1. HTTP requests. C2 servers often communicate with compromised assets using HTTP or HTTPS requests. These requests can be used to send commands or receive data. Number 2, command execution. This behavior is the most common, allowing attackers to execute OS commands inside the machine. And 3, sleep or delay. To evade detection and maintain stealth, threat actors typically instruct the running malware to enter a sleep or delay for a specific period. During this time, the malware won't do anything. It will only connect back to the C2 server once the timer completes. We will try to find these functionalities in the following section. So now we're talking about decompiling malware samples with dnspy. Now that we've tackled the theoretical concepts to build our technical skills, let's start playing with fire, also known as malware. So since we already assumed that the malware sample is written in C#, we will use dnspy to decompile the binary and review its source code. dnspy is an open source .NET assembly, C# debugger, and editor. It is typically used for reverse engineering .NET applications and analyzing their code, and is primarily designed for examining and modifying .NET assemblies in a user-friendly, interactive way. It's also capable of modifying the retrieved source code, editing, setting breakpoints, or running through the code one step at a time, also known as debugging. So as mentioned above, we won't execute the malware, so the debugging functionality will not be discussed in the following sections. To proceed, let's go to the virtual machine and start the dnspy tool by double-clicking the shortcut on the desktop. So we can go to the other tab, and then we can double-click on the dnspy shortcut over here. Okay, so double-click on that. Okay, that's going to open up dnspy. We're going to make this window bigger so that we can more easily see what's going on. And we're also going to increase the magnification here from 100% to 150%. Okay, so what do we do next? Let's take a look at the web page. Okay, once the tool is open, we will load the malware sample by navigating to the File Open located at the upper left side of the application, which is over here. And then when you get the prompt, click the following to navigate to the malware's location at this PC, desktop, artifacts. Now that we're inside the malware sample folder, you need to change the file type to all files to see the defanged version of the binary. Next, double-click the malware sample to load it into the application. So let's do this inside of the virtual machine. Okay, so we go up to here, File, and then File, Open, and then we go to My Computer. So this PC. And then we go to Desktop, and then we go to Artifacts. So this PC, and then Desktop, and then Artifacts. And then we set, we're looking for files over here. We're gonna switch this from .NET executables to all files. And then we see the file over here that we're looking for, which is juicy tomatoy underscore defanged. Okay, so click on that, and then click Open. Okay, so let's go back to the web page and see what we're supposed to do next. Once the malware sample is loaded, you'll have a view like the image below. The next step is to click on the main string, which will take you to the entry point of the application. So we're going to have to click on the main string inside of the dnspy software, which is, we'll go back to the virtual machine, and we'll click on the main string over here. So we just click on that, and that's going to give us an expanded view over here. Okay, so next. As discussed in the previous section, the main function is a class the main function in a class is the program's entry point. This means that once the application is executed, the lines of code inside the function will be run one step at a time until the end of the code block. However, we won't be dealing with this function yet, since reviewing it without understanding the other functions embedded in the malware sample can be a bit confusing. Okay, so to understand the malware functionalities, okay, you might have been a little bit overwhelmed when you saw the main function, but don't worry. we'll discuss the other functions before building the malware execution pipeline. Focusing on the individual functions before dealing with the main function can be considered a modular approach. Doing this allows us to easily break down the malware's functionalities without getting bogged down with long code snippets. Moreover, it allows us to recognize some potential execution patterns that ease our overall understanding of the malware. To start with, view the list of functions inside the program class by clicking the highlighted section as shown in the image above. So we're going to expand on this program tab over here underneath Juicy Tomatoy over here. So we're going to do that inside of the virtual machine. So the program tab is right here. So click on that. And we see a list of different functions over here. Hey Dreamer 1991 says hello. Hello, Hey Dreamer 1991. We're doing our daily challenge today for day 9, which is malware analysis. Nice to see you here. All right, so to start with, so over here, after clicking, you will see the functions in the drop-down menu. Let's run through them individually to better understand each code's meaning. You can click on the items as we discuss them to compare the code in dnspy. It's advisable to read the .NET Framework documentation to learn about the internal functions mentioned in the following sections. Okay, so Hey Dreamer 1991 is confused about this daily challenge. Well, stick around. We'll be walking through it together. So the first function we're going to be looking at is the getIt function. So based on the source code, the getIt function uses the web request class from the system.NET namespace and is initialized in the function's URL argument. The name is already a giveaway that the web request is being used to initiate an HTTP request to the remote URL. Okay, so we can take a look at the getIt function ourselves by going down to this getIt function, this getIt function over here. You can click on it, and then it'll give you a rundown on the code that it uses. Okay, so we see that so public static string getIt string URL. So this is so getIt is the function, and the string and the URL is what URL is being retrieved using it. So Hey Dreamer says, question is not hard, but I didn't decode my brain that codes in variables. Okay. Yeah, so I think if you just sit back and do a little bit of reading and research, we will be able to get the answers to all these questions. But let's move on. So we can render the namespace details by hovering over the web request string, similar to what we see in the image above. Okay, so by default, the HTTP method is set to the web request class, which is get. So this means that we're assuming that the HTTP request made by the function is a get request. So the 3 lines of code inside the function can be expanded by the comments written for every line. So if we click on View Code Snippet, so we can see they've conveniently provided the code snippet for this particular function right here. So in other words, the getIt function accepts an URL as its argument, configures the parameters needed for the HTTP GET request, and returns the value of the response. So the next function we're looking at is PostIt. So like the getIt function, the PostIt function also uses the web request class. However, you might observe that it has configured more properties than the first one. The most notable is the method property, wherein the value is set to post. This means that the HTTP request made by this function is a post request, and it submits the second argument as its post data. Okay, so we take a look at the snippet for the post function right here. So this is posting. This is setting post request via the malware, right? All right. So in simple terms, the PostIt function accepts an additional argument as its post data, which is submitted to the target URL and returns the response it received. All right, so the next function we're looking at is the sleeper function. The sleeper function only contains a single line, a call to the thread.sleep function. The thread.sleep function accepts an integer as its argument and makes the program pause and in milliseconds based on the value passed to it. Okay, so we can see here that that the sleeper function is going to execute this command right here, which is going to make the program sleep for a certain number of milliseconds. The usage of the thread.sleep function is typical behavior that malware uses to pause its execution to evade detection. Okay, so the next function is the execute command function. Given the namespace and class name, system.diagnostics.process of the initialized process class, the first code line, it seems that this function is being used to spawn a process according to its Microsoft documentation. From the initialization of this process start info properties, we can also see that the file to be executed is cmd.exe, and that the execute command's argument, command variable, is being passed as a process argument. So this function right here is being used to pass commands to the computer, to the compromised computer. In short, the code snippet results to cmd.exe/c command variable. All right. So another thing to note is that the Windows style property is set to process.windowsstyle.hidden. This means that the process will run without a window. As such, it's a way to hide the malware's malicious command execution. This function serves as the malware's OS command execution function. So the next function is the encryptor function. Okay, so the giveaways in this function are the AES classes used in the middle of the code block. If you hover over the initialization of the AES managed variable, it shows that the namespace system.security.cryptography, which somehow means that everything here is related to cryptography or encryption. So, moreover, the encryptor function accepts an argument and encrypts it using a hard-coded key and IV values. And lastly, it encodes the encrypted bytes into base64 using the convert.toBase64 string function. In summary, this function encrypts a plaintext string using an AES cipher together with the key and IV values and returns the encoded base64 value of the encrypted version of the string. The next function we're looking at is the decryptor function. This function is the opposite of the encryptor function, which expects a base 64 string, decodes it, and proceeds to the decryption to retrieve the plaintext string. Okay, and it looks like the last function we're looking at is the implant function. The last function is the implant function. It accepts a URL string as its argument, initiates an HTTP request to the URL argument, and encodes it with base64. It also retrieves the app data path and attempts to write the contents of the base64 encoded data into a file. Lastly, if the implanted file was written successfully, it returns its location. If not, it returns an empty string. In the context of malware functions, the implant function is a dropper function. This means that it downloads and stores other malware inside the compromised machine. So let's build our malware execution pipeline. Now that we analyze the other functions in the malware sample, we will return to the main function to complete the malware's execution pipeline. Again, viewing the main function's source code is a bit overwhelming since its code block contains over 60 lines. To make things simple, let's try to split the analysis into 3. So number 1 is the code executed before the for loop. All right, so the first code section before the for loop executes the following. So it's going to retrieve the victim's hostname via dns.getHostname function and stores it to a variable, which is this right here. It's going to initialize an HTTP URL together with the data to be submitted to the /reg endpoint. So it's going to get a string to this particular C2 domain, and then it's going to add to the string /reg, and then it's going to store the data as the name equals to the host name. Okay, and the third thing it does is it executes the HTTP post request to the target URL together with the post data that contains the host name of the victim machine. So it's also notable that the response from the HTTP request is being stored in another variable, another string. So, lastly, it does initialization of other variables, which is included in the following code lines. So, int count equals 15,000, and bool flag equals false. So not completely sure what those do yet, but let's move on. So as you can see, most of the lines in this section are all about initializing values in a variable. However, there are two notable function calls made here. The call to dns.getHostName function, which retrieves the victim machine's host name. This attempts to distinguish the compromised machines based on their host names, which is typical malware behavior. So if you compromise a lot of machines, you have to know which machine is which by giving them all different names. And this is how this malware does it. So we have discussed the post-it function, and we know that it makes a post request to the URL, first argument, and submits the host name as its post data, second argument. So in this initial step, it seems that the malware reports the host name of the compromised machine first to establish the C2 connection before executing other functionalities. So the next part of the main function code we'll look at is number 2, code inside the for loop before the code block of the if statement. So in this section, you'll see that the for loop is written without any initialized values on the initialization, condition, and incrementing sections. For semicolon, semicolon. This means the loop will run indefinitely until a break statement is used. So afterwards, the first line inside the loop uses a sleeper function wherein the count variable is being passed. Remember that this variable was already initialized before the for loop statement. The following code lines are variable initialization, whereas the string and string2 variables are used. Okay, eventually the URL2 variable is used by the getIt function to do a get request passed to the URL and stored in its it variable. Okay. Lastly, the execution flow will enter the if statement only if the it variable is not empty. So we can view a detailed annotations in the code snippet below. So the sleeper function is being used together with the count variable, which was initialized prior to the code block. So if we remember, the sleeper function is going to use the count variable, and the count variable was initialized earlier to 15,000. Okay, so it's also going to initialize other variables such as URL2, which is the same URL but with the tasks endpoint, and URL3, which is the same variable with the results endpoint. Okay, so this is all well and good. We're going to move on. In summary, this section is focused on the preparation of variables to execute the HTTP GET request to the task endpoint and enters the if statement code block once the condition is satisfied. Okay, so number 3, code executed within the first if statement. So this is the last portion of the main function. So continuing the execution flow, this code block will only be reached if the GET request to the task's endpoint contains a value. So here we see that if it is not sleeping, then it will see if the shell command, if the shell variable is passed, and if not, it sees if the implant variable is passed, and if not, it sees if the quit variable was passed. Otherwise, it executes this particular code right here. The section before the if variable a is equal to sleep statement is focused on initializing the values a and text. It starts by decrypting the string stored in the it variable and splits it with a space character. The a variable's value is the first element of the resulting array, and the text variable combines all the elements in the same array, excluding the first element. The example below shows how the it variable is being processed. To simplify, the code snippet discussed above focuses on setting up the values of the a and text variables, which we'll use in succeeding conditional statements. So next we're going to be talking about nested conditional statements. So the next section focuses on the conditional statements based on the a variable's value. You might see that the variables in the if statements are all set to not. This means that if the condition is satisfied, it will go inside the code block to assess it with another condition. So inside of this nested conditional statement, it's looking for sleep, and then shell, and then implant, and then quit. So let's take a look at what the different C2 commands do in the table below. So the sleep function sets the value of the count variable, which is used by the sleeper function. Okay, the shell command uses the execute command function to run OS commands with a text variable. It encrypts the command execution output using the encryptor function, and then it reports the encrypted string to the C2 server using the posted function and the /results endpoint. The implant command executes the implant function with the redacted domain. It encrypts the output of the implant function via the encryptor function and reports the encrypted string to the C2 server using the posted function via the /results endpoint. And the quits command sets the flag variable to true. All right, so this is all a bit overwhelming, so let's summarize the key learnings regarding the code block. The a variable, which is dependent on the GET request made to the /task endpoint, contains the actual instruction pulled from the C2 server. This seems to be the command and control functionality, whereas the malware's succeeding actions depend on the commands that the attacker sets within the C2 server. The shell and implant command responses are submitted as a post request to the /results endpoint. This seems to be the malware's reporting functionality, where it sends the results of its actions back to the C2 server. The instructions pulled from the C2 server are limited to the following: sleep, shell, implant, and quit. Okay, so the last thing is breaking the loop. Lastly, the final conditional statement at the end checks that the flag variable is set to true, and if that statement is satisfied, it will execute a break statement. So this is how the command and control would stop the malware. So it would stop the malware by sending the quit command. This means that the if statement that contains the quit condition makes the indefinite for loop stop, terminating the malware execution flow. All right, so we've completed the malware sample analysis and discovered some notable C2 endpoints that can be used to take revenge on McReady. All right, so we're going to answer the questions below. Which HTTP user agent is used by the malware for the connection to the C2 server? All right, so inside of our DN spy over here, we can take a look at the getIt function. So the getIt function over here indicates a user agent of this right here, and this is the answer. So we copy everything from Mozilla to 1.15, and then we can copy that, and then we can go back to the page and supply that as the answer, paste it in, and click submit. What is the HTTP method used to submit the command execution output? So if you remember that the post-it function uses the post HTTP method, and that is the answer. What key is used by the malware to encrypt or decrypt the C2 data? So we're looking for the key, and that's going to be in the encryptor function. So if we go to the machine and go to the encryptor function, we can see that this string right here is being used as the key because this is used as the bytes. Oh gosh, what is the word? Is the bytes argument, as the bytes argument, and we can see down here that the bytes are used in the create encryptor function right here. So this is the key. So we can copy this. Whoops. You can just use the keyboard shortcut to copy it. And that's the answer there. What is the first HTTP URL to be used by the malware? Well, we can take a look at the main function to figure out that answer. So we go up to the main function right here. And we can see as we just go down over here that this is the URL being used, but it's also going to append the /reg endpoint to it. So it's this, and then copy that. And then we're going to append to that /reg, and that is the answer. Okay, so how many seconds is the hard-coded value used by the sleep function? Okay, so we can see inside of the main variable, the main function over here, the count is initialized as 15,000, but 15,000 is eventually going to be, this is initialized as the count variable, and the sleeper function uses the count variable, which is 15,000. But 15,000, we're dealing with seconds, and this is in milliseconds, so we need to divide by 1,000 to get the answer in seconds. So this is 15 seconds. Okay, the next question is, what is the C2 command the attacker uses to execute commands via command.exe? Okay, so to get the answer here, we need to go back to this section over here, which talks about the different C2 commands. So there's only sleep, shell, implant, and quit. And the one that is used to execute commands is this one right here, shell. So we can copy that and supply that as the answer. And the last question is, what is the domain used by the malware to download another binary? So we can take a look at the main function one more time to get this answer. So we're looking at, oh, there's a bird outside my window. So we can take a look at this implant function right here. And the implant function is reaching out to http://stash.macready.thm. So the implant is using this URL right here. But the answer is only looking for this right here. So we can copy that. And then we can paste that as the answer. All right, so that is, we got a good little overview on how to use the DNSpy software to analyze .NET applications. So, and we also got a nice little overview on how a typical C2 malware is implemented and how it works. I'll admit to you guys that I am not all that familiar with C# programming, but the demos and examples in here made it very easy for us to understand what exactly is going on, even if we don't know exactly what all the lines of code are doing. But thank you very much for joining me today. We're going to end by completing this question right here, finishing off the task. This was a bit longer than usual, but thank you very much for hanging out with us, and we're going to be back tomorrow doing day 10 of TryHackMe's Advent of Cyber event. Thank you very much for joining me today, everybody. And until tomorrow, we'll see you next time. Have a great day. And yeah, we'll see you next time.